A population has a mean of 121. If a random sample of 8 items from the population results in the following sample values, what is the sampling error for the sample? So first of all, if you look at the example or you look in your textbook, you will notice that the sampling error is the sample mean minus the population mean. So we know that the population mean is 121. So you can either do this in StatCrunch or Excel. I'm going to do this one in StatCrunch. You could even calculate your mean by hand, just average the numbers. But if you just want to save time, you can go to Summary Stats Columns, and we want variable 1 column. And you can just select all this if you want to, and we can see that the mean is 128.875. So you take the sample mean 128.875 minus the population mean 121, and you get 7.875. For the next one, it wants you to calculate the mean for the population. So you could go into StatCrunch, or you could go into Excel, or you could calculate it in your calculator. Just find the average. And we can see that the mean is 34.5 for the population. Now, it says calculate the sampling error using the first 5 homes in the first row as your sample. If you want to do this in Excel, that way you can select the first 5 homes. You can open this in Excel. Give it just a second to open. We're going to do it for the first 5 homes and then the first 10 homes. So if we want to do equals average, let me enable editing. Equals average of the first 5 homes, 1, 2, 3, 4, 5. You get 19.8. So you do 19.8 the sample mean minus the population mean, and you get negative 14.7. To do 10 homes, you do the same thing, except this time you take the average of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh. And you get 29. So you do 29 minus 34.5, and you get negative 5.5. And anytime you increase the sampling size, it's more representative of the population. The bigger the sample gets, the closer to the population it would get. So your sampling error should be smaller. And then it says, using a sample size of 5, what is the largest sampling error that can be observed from this population? So what you need to do here is, we know that the mean is 34.5. So the larger or the smaller the mean is from the sample mean, the larger the sampling error would be. So what I did, you could either try your your 5 biggest numbers, and I think in this situation it's going to be your 5 largest numbers. We have 74, we have 60, and just put commas. You can just put this in your calculator if you want to and get your average. 54, 53, and then I think it's going to be 51. So 58.4 would be our mean. And if you do 58.4 minus 34.5, let's see what that would be. our sampling error would be 23.9, which is what we got. So to figure out the largest sampling error, you can pick the 5 smallest numbers and get the mean and subtract the population mean, and the 5 largest numbers. In this situation, the 5 largest numbers were farther away from the mean than the smaller numbers. So that one worked out. Here, same thing, calculate the mean, do the first 4 games, pick the first 8 games, and get your sampling error here. And then same question here, and the largest sampling error for the given data uses a sample size of 4 is 18.6. So you work this one the same way. Same thing here. These are all very similar problems. A simple random sample of 4 items, calculate the sampling error. So you find the mean of the population and then the mean here, and then you subtract the sample mean minus the population. And I think what I was doing wrong is I was adding this in my head, and I was getting 56 divided by 4 instead of 66 divided by 4 here to get this mean, and that's why I missed my number there. Same thing here, you would find the mean here and find the mean here. Take the sample mean, subtract the population mean to get your sampling error. And then down here, as the sample size increases, the magnitude of sampling error decreases. Anytime you increase the sample size, you're getting closer to the population because you're having more numbers, and the more likely your sampling error is going to go down for the most part. And then here, same types of calculations. And then based on what I see here, we see the sampling error was 3, then 1.99, and then it went to 4.43. So the sampling error is greater. So in general, increasing the sample size makes the magnitude of the sampling error smaller. The sample obtained in Part C does not follow this trend, however. So sometimes it won't follow the trend. And then here, be careful here. The presence of periodicity in the data might impact the sample obtained in Part C. And if you will look, if you want to understand systematic sampling, this is a little bit different here. I do need to talk about it. It says draw a systematic sample consisting of 2 temperatures. So the way you pick your sample, you need 2 numbers, and you're going to find the mean of those 2 numbers. So whatever the 2 numbers are, you're going to add them up and divide by 2. Here you would add your 4 numbers up and divide by 4. Here you would add your 7 numbers up and divide by 7 to get your sample means. To get your population mean, you would open these in Excel and average these up to get your population mean. But to get the systematic sample, you have 28 temperatures here. So if you want a sample of 2, 28 divided by 2 is 14. So for every 14th temperature, that is what we're going to select. So for the 14th, that would be 56.3, and then the next 14th would be the 28th temperature. So 56.3 plus 47.5 divided by 2 would be your sample mean. Now for every 4 temperatures, 28 temperatures divided by 4 means every 7th temperature we're going to take. So we're going to do 40.4 and then 56.3. So 7, 14, 21, 43.1, and then the 28th would be 47.4. You would add those up and divide by 4. Now, 7 temperatures, we have 28 temperatures divided by 7. So every 4th one we would pick. So 45.3, 40.6, 4, 8, 12, 49.1, 16, 43.9, then 4 more would be the 20th, 42.2, then the 24th, and then the 28th. You would add those up and divide by 7. So you just take however many you're pulling from, how many you need in your sample, and divide it by the total number you have in the population. And once you pull your samples, you get the mean like you normally would and subtract it from the population mean, which you could open this in Excel to get the population mean. If you want me to show you that real quick, I can show you. The difference between opening in Excel, it takes a few minutes longer than it would if you wanted to open it in StatCrunch. Of course, I have a lot of documents open too, so that kind of slows it down. So we would do equals, oh, let me fix that. Let's do it right here, equals average, and then you would take all of these and you would get 48.81786. And what you have to do is pull your temperatures, and for every sample mean you get here, you take that number and subtract it from the 48.81786. So it's the basic same thing you're doing in all of these. Systematic sampling is a little bit extra, but it's pretty easy to figure out your sample. Just take the number and divide by, take the number you want in your sample and divide it by the total number of data you have in the population. So here for the two temperatures, just to show you, every 14th, 56.3 and 47.5. If you do 56.3, every 14th, so that would be the 14th and the 28th. Alright, if you take the average of those two and you do the sample you just got, the sample mean minus the population mean, you would get 3.0821. That's how we get 3.08.